beginning, there was darkness, and then bang, giving birth to an endless expanding existence of time, space, and matter. Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. Did a comet slamming into the ocean cause the biblical flood?
The tsunami wave itself was at least 50 meters high.
Did a fiery messenger from space reverse the fate of Christianity?
Suddenly, at 70,000 miles per hour, this meteor comes crashing to Earth.
Did a fireball in the sky wipe out the first North Americans?
Space literally has changed history time and time again.
A maverick group of scientists is on a quest.
Very large comet impacts could have changed the course of human civilization.
A quest to defy mainstream science and prove that human history was wrought with catastrophic moments when space changed history. "40 days and 40 nights of torrential rains." The Bible's Great Flood and the Epic of Gilgamesh are widespread myths that depict an event that wiped humanity off the face of the earth. But was it simply a myth, or did it really happen? And if so, how can science explain such a catastrophe?
There's no reason that very large comet impacts could not have occurred during the last 15,000 years. And there could have been even a globally catastrophic event that could have changed the course of human civilization.
Archaeologist Bruce Massey is a member of a small group of maverick scientists called the Holocene Impact Working Group. It's named for the Holocene Epic, which began 10,000 years ago. His group has roiled the world of astronomy by claiming that catastrophic impacts have occurred much more often than supposed and have actually changed the course of human history. Case in point, the Great Flood. The biblical story of Noah's Ark is simply one version of an ancient story that's found in dozens of myths and legends across the globe.
What I decided to do is to take a look at this worldwide distribution of flood myths, take a sample of those myths. And the sample I selected was 175 locations from across the world.
Most of these flood myths contain striking similarities, including the common legend that just before the flood began, a celestial creature with impressive tails raced across the sky.
Since they didn't have a science to understand what comets were all about, they would try to come up with a natural solution. So therefore, a comet might be a snake.
Comets are known to have tails, the visible effect of two byproducts: dust reflecting sunlight and glowing ionized gases roaring off the back like jet contrails.
Interestingly enough, you can actually have what's called an anti-tail, where from our point of view, it looks like the tail of the comets are actually pointing in two totally different directions. So as solar radiation streams off of our sun, it tends to make the material that's evaporating off of the comet appear to recede away from the sun.
As seen from certain spots on the Earth, the dust tail can sometimes curve around so that it appears to point in the opposite direction.
So observers on Earth would see an object in which it looked like there was a head with a headrest or a horn coming out of its head. In North American mythology, South American mythology, it's a serpent with a horn on its head. In Hindu, it's a fish with a giant horn on its head.
In most myths, the creature's arrival was followed by a watery disaster that almost destroyed the world.
If you look at other aspects of this mythology, it's talking about then darkness, hurricane force winds, it's talking about torrential rainfall, talking about tsunamis. Now, if you add all of that information together, these are the properties that you would get from a deep water ocean impact of a comet.
If a comet were to strike in the open ocean, you would really get a massive amount of energy delivered into that part of the ocean that it hit.
The amount of water injected into the atmosphere would be colossal.
We're here visiting a forge and a blacksmith shop to show what would happen when a comet comes in at high speeds and impacts the ocean, delivering all that kinetic energy into the water.
A typical forge can heat carbon steel to approximately 2,200 degrees Fahrenheit. But a hypervelocity comet strike will produce shock temperatures well over 10,000 degrees, hotter than the surface of the sun.
A comet coming in from outer space would be carrying with it an immense amount of kinetic energy because it's moving at such an extreme velocity. When that impacts the ocean, that energy is capable of vaporizing up to hundreds of square kilometers of water, sending plumes of steam up into the outer atmosphere.
Normally in the upper atmosphere, there's only about 0.5% of water vapor. So you get this injection of this large amount of new water vapor.
As a massive infusion of water into the atmosphere rains down, a global deluge could drown the Earth for weeks or months. Bruce Massey believed he had found a possible source of the worldwide flood myth: a massive comet strike. But he lacked the physical evidence. Columbia University geologist Dallas Abbott investigates potential cosmic craters.
Bruce Massey had compiled a set of oral histories of catastrophic events that sounded like they were some sort of cosmic impact, and he found that the center of them was around the Indian Ocean.
Using bathymetry readings, or satellite measurements of depth variations in the ocean floor, Abbott was able to pinpoint a potential impact zone. She named it Burckle Crater in honor of a colleague at Columbia University. Burckle is a massive depression located nearly 1,000 miles off the coast of Madagascar. About 18 miles in diameter, Burckle Crater lies at a depth of approximately 13,000 feet, making an extensive study difficult and expensive. But a crater this big would produce another logical fingerprint of a massive comet impact: a mega tsunami.
A comet hitting the ocean would actually be more damaging than a comet hitting solid ground. And that's because it would send up a gigantic tsunami that would slam into the coast all around it.
When massive tsunamis strike shorelines, the evidence can persist for centuries. Abbott turned her attention to the shoreline of Madagascar.
At the time, I couldn't get data on Madagascar. But the minute Google Earth came out, I went and I looked at Madagascar, and the tsunami deposits there were phenomenal. I immediately found these huge chevrons, which I think are probably the biggest chevrons on the planet.
chevrons are symmetrical sand dunes found along coastlines around the world. Some believe they form when massive waves slam into the coast and then recede. Their distinctive V shape may even serve as a directional marker.
The back azimuth is the V, so this is inland. V points inland. The back azimuth of the V, that tells you where the source is.
Abbott claims that source is Burckle Crater, located hundreds of miles offshore. But others doubt that tsunamis have anything to do with chevron formation.
The geologists that actually go to the sites and do field work and have looked at these, they don't associate those with tsunami. They associate those with wind-blown dust. And so I'm skeptical that these things have anything to do with tsunami waves.
But when Dallas Abbott traveled to Madagascar, she found surprising evidence trapped inside the dunes.
We found tsunami deposits over 200 meters high. And when we got to the top of this big hill, we found marine fossils in the sediment. And we found it in all of the locations where we looked. Hurricanes bring in marine microfossils, but they only bring the kind that live in the top of the water column, whereas the kind of marine microfossils that live on the ocean bottom, they don't get transported by things like hurricanes. Well, the Madagascar fossils are dominated by the ones that live on the bottom. And so they absolutely can't be just wind-blown fossils.
For members of the Holocene group, the chevrons and the microfossil evidence are the smoking gun. When connected to the flood myths of ancient societies around the world, they help paint a compelling picture. But the flood-comet hypothesis contradicts the firm beliefs of many astronomers. Cosmic impact astronomers, like Mark Boslow, believe that catastrophic impacts during the last 15,000 years simply never happened.
Anybody who would claim that there have been environmentally damaging impacts during the Holocene, during the era of humans, has a very high burden of proof because the probability that such a thing even once would have happened is very small.
The response has been that extraordinary claims require extraordinary evidence, because nobody believes that an impact crater is confirmed until you actually go to the crater and you've got samples of the impact melt body. We still, at the moment, don't have the evidence to prove Burckle Crater.
In the meantime, the Holocene Impact Working Group believes it has found evidence of a far more recent impact. The evidence, they say, lies buried in the ice sheets of Greenland. And they say it points to a comet that helped push Europe into the barbarism of the Dark Ages. In the search for extraterrestrial impacts that have changed history, certain facts are not in dispute. Sometime in the year 535 AD, something descended like a gray veil over planet Earth. It created the most severe cooling period of the last 2,000 years and plunged humanity into an unprecedented crisis.
During that time period, a very, very large quantity of ash completely enshrouds the Earth. It cuts sunlight off from crops that are growing on the ground. It kills off crops that are under cultivation. It leads to famine because it interrupts the ability to produce food for the civilizations that were present on the planet at the time.
We know from historical data that starting early in 536 AD, the sun became very dim. And in Mesopotamia, the sun was dim for 18 months. And they said that during that time period, the sun came out for about 4 hours a day.
The signature of this year without the sun remains to the present day. Tree ring data from Ireland and California shows the unmistakable signs of dramatic global cooling.
The tree ring evidence clearly illustrates that there was a period in the 6th century where nutrients that make a tree robust, that make it grow quickly, those nutrients dwindled down to a very, very low level. And so the tree rings are extremely close together.
The accepted theory blames a massive volcanic eruption and a global ash cloud. But impact researcher Dallas Abbott has proposed another culprit. Beginning with evidence based on chevrons, the V-shaped sand dunes that some believe are evidence for mega tsunami. One set of chevrons is located in Australia's Gulf of Carpentaria.
I looked in satellite altimetry for something in that part of the Gulf because the chevrons were pointing to a very, very small area. And immediately I found these 2 round holes in the bottom of the Gulf.
The craters measured 7 and 11 miles in diameter, respectively. A detailed study of sediments pointed to an extraterrestrial invader.
This is a deep sea core sample like the ones we studied in the Gulf of Carpentaria. And when we sieved the Gulf of Carpentaria samples, we found little bits of rock, we found little bits of glass, and we also found some shock minerals. And together, these are indications of an impact. And they suggested that the event was about 1,500 years ago. And I knew about this climate event in 536 AD. And I thought, well, it would be really nice to look at an ice core to see if we can see something.
An ice core is planet Earth's frozen filing cabinet of climate data, trapping centuries worth of airborne particles and algae.
We found samples from Greenland, which is about as far away as you can get on the planet from that site in the Gulf of Carpentaria.
The ice cores yielded startling evidence, including magnetized melted rock called spherules that matched those retrieved in the Gulf of Carpentaria. 2 types of glass that appear to have formed in a high-energy impact. And a misplaced diatom, a marine microfossil that exists only in the tropics.
So why should you be getting diatoms that originated in the tropics to subtropics all the way to Greenland? Nobody has ever found diatoms in Greenland that came from the tropics to subtropics.
The microscopic evidence pointed to a celestial impact.
What happens is you get a huge explosion, and then this material goes up into the air and travels for hundreds or even thousands of kilometers. And then it's, settles out.
For a cosmic impactor to create a global atmospheric effect, like the one suspected in 535 AD, it must have enough mass and velocity to create an epic explosion.
The difference between a high velocity and a low velocity impact is a low velocity impact does not create an explosion. It can make a crater, but it's not an explosion crater. What we're doing here is setting up to do a simulation of a hypervelocity impact in the formation of a crater. And we're using ammonium nitrate mixed with fuel oil. So when we set it off, it's going to explode and make a huge crater. It's a massive explosion that creates a big plume of debris that gets scattered for many, many miles around. And for the biggest impacts, it's a global phenomenon. If this crater had been actually formed by an impact, it would be an explosion crater because the object coming from the sky is going so fast with so much kinetic energy that it penetrates below the surface and heats up, vaporizes, and explodes.
A high-velocity strike in the shallow waters off Australia could have produced an explosion large enough to launch sediments and particulates high into the atmosphere.
You can imagine that that'll get kicked up really high and that you'll have a lot of particulate matter up in the high atmosphere where it can block out a lot of the sun.
The disastrous events of 535 AD seem to fit the signature of an impact followed by a dimming of the sun. But finding the proof that it all started with a cosmic impact is more difficult, especially when one glaring question remains. What massive space rock could produce two craters side by side? They are considered heretics in the mainstream world of astronomy, but the scientists belonging to the Holocene Impact Working Group are determined to prove that space has changed human history. One such event may have happened in the year 535 AD, when a sudden darkening of the sun caused crops to fail, leading to worldwide famine. Scientific tree ring data proves the catastrophe happened, but science has yet to determine what actually caused it. In 2008, cosmic impact researcher Dallas Abbott discovered what appeared to be two huge craters in Australia's Gulf of Carpentaria. She believes they were put there by a comet.
Well, the mainstream idea is that impacts are very rare and that most of the impacts that happen are asteroidal. But the data that we're finding suggest that the impactors that hit were cometary rather than asteroids.
Composed of rock, gases, dust, and ice, comets are known to break apart when they encounter the gravitational pull of large objects like planets. In July of 1992, the Hubble Space Telescope recorded exactly this scenario. As comet Shoemaker-Levy 9 hurtled past Jupiter, the planet's immense gravitational pull tore the comet apart.
Comet Shoemaker-Levy 9 broke up into several dozen fragments, the most massive of which created an explosion equivalent to 6 million megatons of TNT. Now, the biggest bomb ever made on Earth is the Tsar Bomba by the Soviet Union, which was 50 megatons. A single impact from Shoemaker-Levy 9 was 100,000 times more powerful.
Could a Shoemaker-Levy 9 type breakup have created the dual craters in the Gulf of Carpentaria? The hypothesized dual impacts appear to fit the comet profile. But it's not a fit with mainstream science.
A comet impact itself is very rare, once every 100 million to billion years. A comet cluster would be much more rare even than that, so rare that you wouldn't expect it to happen on the age of the Earth.
The search for positive verification of an impact in the Gulf of Carpentaria continues to generate scientific controversy. But no impact hypothesis is more controversial than the question of what wiped a famed North American culture from the pages of history. Millennia before European colonists claimed it as their own, another group of immigrants dominated North America. That is, until someone or something wiped out the Clovis people.
Clovis were an ancient Paleo-Indian people that lived in North America. Some people believe that they were the first people to live in North America and that they came across the Bering Land Bridge and radiated down into the Americas from the north moving south.
Archaeological evidence, including their famed spear points, reveals the Clovis people thrived during the last great ice age by hunting the megafauna, including huge mammoths and mastodons.
There was a moment where the population of megafauna in the Americas changed. The megafauna suddenly began to disappear. And as they went down, they brought the Clovis down with them.
Approximately 13,000 years ago, something happened. Something changed the environment. It changed it rapidly and profoundly. And all of a sudden, the planet was thrown back into a little ice age, a climatic event we call the Younger Dryas.
After many thousands of years of retreating glaciers and warming temperatures, the Younger Dryas period reversed the warming trend and wreaked havoc on man and beast. But scientists argue fiercely over the reasons for this climatic U-turn, especially one hypothesis that places the blame squarely on outer space.
The Clovis hunters were having to adapt to new conditions. And one of those changes could have been a comet impact over the Laurentide ice sheet.
The Clovis comet is perhaps the most controversial impact hypothesis championed by the Holocene Impact Working Group. It claims that a comet strike into the North American ice sheet allowed large freshwater lakes to drain into the ocean, altering ocean currents and triggering the Younger Dryas cooling period. Ken Tankersley, a University of Cincinnati anthropologist, uncovered cosmic impact evidence in Sheridan Cave in northwest Ohio.
The layer which we found here is known as the black mat. It's a very carbon-rich layer, which in this case is the result of intense burning. It's composed of wood charcoal and the burned remains of approximately 70 species. It takes an intense fire, an intense burning, almost an explosion, if you will, to produce this type of carbon event.
The layer also contained meteor fragments. But more importantly, seeming indisputable evidence for a larger cosmic impact.
We have what's called impact diamonds. Impact diamonds or shattered diamonds occur when some type of explosion or sudden impact occurs with the Earth's surface, compressing carbon material to create these impact diamonds.
Also called nanodiamonds because of their minuscule size, they are recognized as powerful evidence for cosmic impact. But their discovery raises many more questions.
The supposed presence of nanodiamonds in certain locations of North America isn't compelling evidence for the Younger Dryas impact hypothesis, because in some cases it's not even clear that those are genuine nanodiamonds. They may be graphite or graphene compounds that kind of masquerade as nanodiamonds.
The proposed Clovis comet also appears to be missing one huge physical piece of evidence: an impact crater. To date, no telltale crater has been found. But space rocks don't have to impact the Earth to ignite a catastrophe. We know because one very nearly touched off a thermonuclear war. In the face of widespread skepticism, a small group of impact researchers claim that very recent cosmic catastrophes have changed human history. 13,000 years ago in North America, something suddenly sent the Clovis culture into a tailspin. Some scientists believe that a comet is to blame. But to date, no impact crater has been identified. But some cosmic projectiles never reach the Earth. Yet they can still rain down destruction in the form of an airburst.
An airburst is when a meteoroid or a comet explodes in the atmosphere before reaching the Earth's surface, so it doesn't produce a visible crater. A truly excellent example of what is thought to have been an airburst is the Tunguska event over Siberia in 1908. It leveled 2,000 square kilometers of forest, but there's no impact crater.
When a comet or an asteroid hits the Earth's atmosphere, it actually creates a wake, very much like the wake in front of a boat. And that shock wave, the shocked air, gets to super high temperatures and it radiates. It radiates light and infrared radiation, and then that heats up the comet or asteroid and causes it to vaporize.
Even a smaller Tunguska-sized meteor, around 200 or more feet in diameter, can produce an airburst with 1,000 times more energy than the atomic bomb dropped on Hiroshima. Some 13,000 years before the Tunguska impact, the Clovis comet could have delivered a similar airburst. But the North American landscape would have long ago swallowed all traces. Whether it was a ground-impacting comet, an airburst, or neither one, this climatic event and its effect on the Clovis culture remain a hotly debated topic. But solving the mystery is crucial, since the same thing could happen today with little warning.
Now, an impact like the Tunguska event, a 10 megaton airburst, say at 5,000 meters over New York City, if that were to happen today, would lead to the deaths of almost 2 million people, another several million people injured, and a couple of $1 trillion of damage. So even airbursts, small events, are something that are very destructive.
In fact, they are so potentially destructive that when a very small meteor exploded in 2002, it could have sparked a thermonuclear war.
In June of 2002, an event occurred that could have changed history on Earth in a major way. A rather small meteoroid, maybe a couple of meters in diameter, smashed into Earth's atmosphere, creating an airburst, an explosion up there.
And this was an enormous explosion over the eastern Mediterranean. It was observed by satellite. This was unusual to be over, a relatively populated area.
At the time of the airburst, Pakistan and India, two nuclear-armed countries, were embroiled in a hostile military standoff over the disputed Kashmir region. The world held its breath as the two nuclear powers teetered on the hair-trigger brink of war.
So had this impact occurred just a few hours earlier, it was at about the right latitude to have been over Pakistan or India. This could have been mistaken by either country as a launch against them. And they then might have pushed the nuclear button, launching an all-out war. A mistake, basically, caused by an impact.
Now known as the East Mediterranean event, the blast convinced the scientific community that predicting cosmic intruders is critical when nuclear Armageddon is at stake.
The vast majority of objects that hit the Earth's atmosphere are unexpected. The big asteroids, the ones that could create a global catastrophe, we've discovered almost all of those. They're cataloged, they're tracked. And so we don't expect one of those to come out from nowhere and hit the Earth because we can see them. It's the small ones that can catch us by surprise.
But how much notice can we expect if one of these massive space rocks moves onto a collision course with the Earth? That's the question that Mary H. from Lincoln, Nebraska wanted to ask the universe.
Mary, that's an interesting question. We'd like to know about incoming comets and asteroids as far in advance as possible in order to deflect them. Now, asteroids might be found tens or even hundreds of years before they hit Earth, allowing plenty of time to do something about them. Comets might come in with very little warning, only a few months or a year or two at best. We might not be able to deflect them.
There is no dispute that comets and other cosmic projectiles have the potential to cause catastrophes. But before modern astronomy began to demystify them, the mere sighting of a comet or meteorite had the potential to change human history. The year is 312 AD. The mighty Roman Empire is embroiled in a bitter civil war. Marching into battle, the Emperor Constantine is about to meet the armies of his arch-rival, Maxentius. The political fate of the empire is at stake.
Constantine was a Roman emperor, famous for a number of things, not the least of which is his conversion to Christianity. Constantine's adoption of the Christian religion in the 4th century is instrumental in the sudden popularity and the spread of that religion by suddenly converting the Roman Empire to a Christian empire.
Many believe Constantine's fateful conversion occurs when he sees a fiery cross above the sun. Interpreting this as a sign from the Christian God, he commands his troops to paint crosses on their shields. Constantine's troops emerge victorious. Soon after, the emperor signs the Edict of Milan, setting the stage for the ultimate triumph of Christianity over paganism. But some believe Constantine's vision has an astronomical explanation.
It's believed now that what he personally observed was a meteoric impact against the Earth, that he's looking skyward in broad daylight and suddenly at 70,000 miles per hour, this meteor comes crashing to Earth. His vision in seeing that is, he interprets it as being a divine signal.
There is one powerful clue that could help validate this cosmic event. A crater. And a team of geologists may have found it in the hills of central Italy. Have cosmic impacts altered the course of human history? It's a question that provokes the world of astronomy and even the world of religion. In the year 312 AD, the fate of Christianity may have been decided by cosmic intervention. Just before a decisive battle, the Roman Emperor Constantine experiences a vision.
He remembers seeing something in the sky. He interprets this as being a sign from God, a sign from the one true Christian God.
Some believe this fateful vision was a fiery meteor on a collision course with the Earth.
What you would see, of course, would depend on how far away you are. You would see an extremely bright meteor coming through the sky, and you'd see it even in the daytime. It would be blinding, perhaps as bright as the sun, and then it would hit the ground and you would see a big explosion.
According to a Swedish geology team, Constantine's meteor might very well be real, and there's a crater to prove it. In 1999, the team discovered a mysterious body of water in the highlands of central Italy. They claim the small lake and some 20 nearby craters are the results of meteorite fragments. But the evidence is far from conclusive. Some think the craters are ancient man-made reservoirs. Others suspect they only date back to World War II.
There's ordnance from some of the craters that suggests that they are actually bomb craters.
The problem is it's in a place where there've been a lot of people, and it was perhaps used as a watering hole. It's been so overprinted by human activity, and I don't know if that one will ever be resolved. But it certainly could be a crater.
One of the weakest parts of the Sorrente crater impact hypothesis is that the shocked minerals simply have not been found. There's no clear evidence that there was a whammo-type impact there.
Cosmic impact or not, Constantine's vision is considered one of the most pivotal events in human history.
Had it not been for this event, would Christianity have become the dominant religion of Europe and then spread to the Americas? It's hard to say, but it's easy to say that this one event was pivotal in forcing Constantine to fully embrace the Christian religion.
We live on a planet ceaselessly shaped by the cosmos and occasionally by invaders raining down fire. The power of space to alter human history remains controversial. But the question remains, how often does it happen? For members of the Holocene Impact Working Group, the answer is far more frequently than mainstream science currently accepts.
So impacts over the course of human civilization in the last 10 to 15,000 years, there's no question in our minds, have played an important role in the development of human evolution and the evolution of human civilization.
But others hotly disagree.
There just aren't enough potential impactors out there to have hit the Earth. And the kind of rates that they're suggesting, kilometer-sized objects hitting the Earth every few thousand years, I mean, if there were enough objects to hit the Earth at that rate, we'd be getting near misses. We'd be getting objects that size coming between the Earth and the Moon, you know, 1 or 2 of those a year. And we've never seen anything like that. The rate just isn't there.
The debate will continue to rage, perhaps until the very end of human civilization. But will that end be a gradual demise? Or a sudden violent demonstration of how space can change history?